thank you. So, question. Do you guys like shortcuts? Right, so today you can kind of see the name of my presentation is Cheat Codes to Unlock the Power of Graphs and Level Up Your Analytics Skill Set. So now, I just want to point out a couple of issues here. So first of all, I accidentally prepared this presentation probably about twice as long as the time I actually have available here. So I actually have a sort of more detailed version of this presentation, which you can check out on my website as well, which is www.datastrategywithjonathan.com/p/graphs. So if you go there, you can check that out, and there's a little bit of code that you can download as well, which will kind of help you along with some of the examples. And to cut my time even shorter, I noticed how everybody's like really interested in Shiny. So one of the things I wanted to attempt to do is actually try and teach you something about Shiny, which should have the time that it takes to actually learn and do Shiny development, which hopefully you have not learned yet. So should be interesting. Yeah. So anyway, this is me. Just a little bit about me. I love data. I love R. So much so that after working with data and R all day long, I go home and yeah, make some R courses as well. So, okay. So, what are graphs and why are they useful? So, currently, as mentioned, I'm working with HSBC and I'm helping with their organizational design strategy. And well, organizations are very much a graph. So here we have these circles and lines, right, which are basically nodes and edges, which are the relationships between all those different nodes. So the circles are your employees, and this is basically a management hierarchy. Okay. So a very common misconception is that a graph is just a visualization. And really, it's a lot more than that. So here we have a graph, and management loves to see this kind of thing for reorganizing, redesigning the organizations. This one is actually done in Microsoft Visio. You can actually import a spreadsheet, and you can turn out something like this, which is kind of handy. And so, you know, there's often this misconception that it's just a visualization. It doesn't help the fact that we also have things like bar graphs and pie charts, which people also consider graphs. But in graph terminology, these are not graphs. These are called charts. So graphs can be visualized, but really that's just the tip of the iceberg. And the really exciting stuff is all the stuff that actually goes on below the surface. So a few different examples of what you could do with graph analytics. You might have heard of a little search engine called Google, which kind of revolutionized search. They use the PageRank algorithm. So I'm not going to go into too much detail about that here, but that's basically a modified graph algorithm. We also have things like social networks, route finding, and recommendation engines. Right? So all very powerful, useful applications of graphs. OK, actually, let's just go back to this for a sec. So one thing that I want to kind of point out here. So currently, I'm guessing most people work with data frames, data tables or tuples, right? So basically, very kind of tabular data. And one of the unique aspects of graphs is that instead of just dealing with records, you're dealing with the relationships between those records. So everything here, you'll notice there's a lot of emphasis between the connections between all of these different points, right? And so instead of when you're working with a database and you've got two tables and you want to join them, you're basically connected by your primary and foreign key, right? There isn't actually a specific location for storing information about that connection or that edge or that relationship between those 2 points. Whereas with graphs, you can kind of build those out and add a lot of additional information to the edges as well. So here's a little example here. This is a graph query on the right-hand side here. Now, this is a query language called Cypher, which is using a graph database called Neo4j. And I'll talk about how that kind of links in with the kind of our world in just a sec. And over on the right here, we have a really, really long SQL query. So this is basically finding all the direct reports and how many people they manage, each up to 3 levels down. And the thing is, with normal kind of databases and joins, you're having to end up you need to do a lot of recursion and all of this type of thing to be able to write this, which is why you end up with this really long, horrible SQL query. And it's not just long, it just performs really, really, really slow as well. So we can express questions much more effectively when using graphs for certain types of data. OK, so here's some of the kind of different technologies that we're using here. So starting on the left, we've got Neo4j, which I was talking about. So this is a graph database. You can link to that graph database using a library called Neo4j, right? And you can query that using its query language called Cypher, right? Now, a lot of times in your organizations, most data is usually kind of relational. So you can also kind of connect to relational data and transform that into sort of graph type of data, but then you need some sort of transformation step, which is kind of more work, basically. So once the data is in R, we've got a few different packages for analyzing this data. So the first one is iGraph. And so when I originally wrote this presentation 9 months ago, I was predominantly using iGraph for a lot of the work. iGraph is very fast. It's a very powerful library. It also has something like over 900 functions. So if you're new to graphs, it's really, really, really hard to kind of get your head around what you actually need to be using. So a package that has come out, which is kind of a wrapper to iGraph, is tidygraph. So we'll talk about that in a sec, but it's basically iGraph plus tidyverse, and you get all kinds of wonderful things happening there. And then, once you pull into R, you can obviously also use all your R techniques and stuff as well, your regression, machine learning, all that kind of happy stuff as well. Now, in the presentation layer of this, there's a few ways of working with this. So the author of the tidygraph package, he also came out with a package called gggraph, which is effectively the graph version of ggplot. But what I actually like to use is a library called Viz Network. This is a very, very nice library. It's for working with graphs. It's a wrapper for the Viz Network, the Viz.js library, which is a JavaScript library, except you don't need to learn any JavaScript, which is fantastic. And I'm also using Shiny Flex dashboards. Now, this is the point I just wanted to emphasize a little bit more here, because so far I've only seen sort of one other presentation, which is using Flex dashboards. And I think this is actually something really, really helpful. So if you were here yesterday and you saw the keynote speech by Garrett, and he was talking about reproducible research using R Markdown. And I love this analogy, how he was basically saying, well, R Markdown is like if you took Word and R and then they had a baby and it got bit by a radioactive spider, then that would be R Markdown. Now, just imagine for a sec if that baby grows up and gets married to Shiny, right? That's what Flex dashboards are, right? So this is the reason why Flex dashboards are so powerful. Traditional Shiny does not use R Markdown. It uses Shiny functions, whereas Flex dashboards is all Markdown, and then you can just kind of embed Shiny into it. Now, the really, really cool thing about this is you might hear about scaling Shiny applications, right? Now, with Flex dashboards, because you can use them with or without Shiny. And the really cool thing about this is one thing that's really, really popular for massively scaling websites and applications and stuff is something called static pages, right? So if you've heard of things like Jekyll and stuff like that, these scale massively because they don't take any resource on the server. You only need to deliver the page, right? And this is the other thing that kind of Flex dashboards can do for you by disconnecting it from Shiny, you can basically stuff it through purrr, like generate all your permutations of your ports, send it out, and you've got a massively scalable BI solution. So, and on top of all of that, it takes about half the code of a regular Shiny app. So, just wanted to point that out. Hopefully, you find that kind of useful. Okay, so going back to graphs again. TidyGraph is equal to iGraph plus tidyverse, right? So here's a little bit of code here. So we've got, it's quite useful to be able to generate various sample graphs. So if you're doing some graph network analysis, before going off and writing all of this code to work on a massive, massive set of data, the first thing you want to do is create a little sample graph where you can test your code, and there's the code here. So again, with TidyGraph, we can use our mutate functions and basically just treat the nodes and edges like two data frames or two tibbles. Right. OK, so one of the kind of key concepts for graphs is sort of graph network traversal, right? So you can sort of kind of go through all of the different nodes in sort of different patterns. And here's the kind of two key patterns here. One is called breadth first search. And all that means is that you're going across, so from node 1 to 2 to 3, 4, 5, 6, 7, and it's going across before it goes down. Now, depth first search, in short, is basically the other way around. It goes deep before it goes wide. So you're going 1, 2, 3, 4, right? And then back up the tree, down to 5, and it's going down before it goes across. Now, why do you actually really care about that? Here's a couple of applications that you might find interesting. So breadth first search, the nature of it is because it goes across before it goes deep. If you set a sort of node and a target, the first time it hits that node is pretty much guaranteed to be the shortest path. So if you're trying to find the shortest path to something, then you can use a breadth first search algorithm. Depth first search is really interesting because it's actually quite useful for things like simulation, like game simulation here. So here you have a game of chess. You have player 1 make a move, player 2 make a move, kind of back and forth, until you end up with an outcome which is either win or lose. Now, if you end up in a loss outcome, you basically back up one layer up the tree and go to the next level down. And you just keep on iterating that way until you end up with a win, and then you kind of play out that path. So very, very interesting stuff. OK, so here is a little bit of code here. So the nice thing about the TidyGraph package as well, it offers you all of these kind of functions kind of built in. So here we've got see my mouse there. So map BFS. So this is kind of map, like the same kind of map you get from purrr. Or if you're not familiar with purrr and tidyverse stuff, then that's basically apply. So map BFS, and of course tidyverse stuff. It's all nice and type safe, and the back is basically the direction of travel, basically, right? So so we've got this function here, and inside this we have business logic. So you can apply very, very simple business logic to figure things out. Now what this is basically doing here is, so within an organization, you got employees, and you want to figure out how much like little sub-organizations are being paid, right? So this is kind of representing the different employees' pay, and if we rolled all of those up at each and every one of the different nodes, that's how you do it. And it's basically just a sum of pay for the node and the path that the node travels down. So all of the nodes in that path. So pretty cool kind of stuff, I think, anyway. So okay, so this is a question that our stakeholders came up to us with. So find the first approver in the parent hierarchy at least 2 grades higher. So let me just give you a little bit more background behind this question. Within an organization, say somebody needed a pay increase or something, they would need an approver to do that. Now, what our clients basically said was that the person who's that person's manager may not be senior enough to actually make that approval. So what we want to do is actually find the approver 2 levels higher than that employee. And so this, again, was a very, very kind of nice graph question, because you could basically just traverse up the tree to figure that out. So this is what the code looks like here, and I'm just going to go over this really quickly, but basically we're using another map breadth first search formula, and the formula, the business logic in the middle is just greater the employee minus greater the manager, greater or equal to 2, and take the first one, right? So very nice, kind of simple business logic to be able to express these things without having to do kind of all these iterations and loops and dealing with all the sort of nasty stuff like islands and all kinds of things that you would have to do manually with trees. Now, what does this kind of look like in practice? So here is application I built. So all the everything I built here is all in Flex dashboards. I highly recommend them for kind of all Shiny applications, you know, to be honest, in my opinion. So the data here is this is a sort of HSBC organizational data swapped out for Star Wars data, right? So over here we've got all our employees like R2-D2 and Yoda and all those characters you know and love. So what's happening here is that in this data table on the side here, and this is DT, or the data, JavaScript data tables as opposed to data.tables from R. And this is showing how many approvals each manager would need to make based on kind of the criteria from our previous kind of business logic, right? And what you see here, and when I start kind of changing these parameters, the visualization updates the size of the node to reflect how many approvals each manager would need to do, right? So that's basically that there. Okay. So another kind of organizational design theory is something about spans and layers. So this is kind of looking at, let me just kind of play this. So we've got a whole bunch of red nodes here, and this is basically saying that these managers are managing too many employees, and therefore they can't manage them all, and therefore, you know, all these employees are going to be sad and leave. So what happens if we kind of play around with those parameters? Kind of what does it look like? So we can play that. So this is just kind of tweaking some of the parameters. It just kind of changes the highlighting on, you know, what we classify as high span or low span, and then kind of showing how you can use this to drill into that employee's, you know, like those managers' direct reports, right? So pretty cool. Again, this is one of the benefits of using Viz.js as opposed to some of the other packages for visualizing graphs. Okay. Okay, so another question that we were asked about was finding outliers. So here we can color code our graph in lots of different ways. So we can group up. These could be things like a department, business framework, region, country, all those kind of things. So right now here I've got this sort of drop down on species class because it's Star Wars data. But you can see that we've got, it's all predominantly yellow with a kind of few outliers. It's pretty small, but if you can see those kind of little blue ones, you could potentially kind of drill into those to see, you know, why are those people kind of in my organization? So here I'm just changing a few of the kind of filters and stuff as well. So I can go, okay, well, if I look at this by a different type of grouping, I can see, okay, well, this is mostly kind of blue and red. I've got this little orange little slither over here. So in this drop down here, this is basically adding sort of additional attributes to the nodes so that you can hover over the nodes to kind of see those details. And then you can kind of zoom in and kind of see what those are. Click on it, all that kind of neat, fancy stuff. Yeah. Okay, visualizing large networks. Now, so far, we haven't really visualized more than like a few thousand nodes, right? Now, the problem is that HSBC has, you know, basically over a workforce of over 280,000 people, right? So a lot more than what we're looking at here. Now, the problem with visualizing a lot of data is that you end up with, actually, let me show you this one first. So right now here, we're looking at 3 nodes, right? So not too much here. So this is kind of what I'm using to kind of demonstrate visualizing a lot of stuff. But it's also the other cool thing that I want to point out about this as well that I think is kind of cool and kind of geeky. But basically, all of these nodes here are being generated on the server, and then they're basically being passed back to the JavaScript object where they're being rendered on the client side without having to kind of reload or redraw the JavaScript object, which is really pretty cool. Anyway, so there you go. That's what 1,000 nodes look like. What happens if you kind of start to visualize more? Well, you end up with something like this, which is called a graph hairball. And one of the things with this is that there's not so much information that you kind of pull out of this, right? It's very kind of hard to see and look at, and it just takes a really, really long time to actually render any of this as well, right? So it takes a really long time to load and to do any analysis on. So, you don't really want to be visualizing this type of thing. So what are some of the alternatives? What are some of the smarter ways that we can actually get better insight out of our graph networks? Well, here we have the entire organization, right? So here we've got 280,000 employees, so for Star Wars characters. But this time, all of the data has been aggregated. So it's been aggregated into different groups. So this could be something like, for say, region and country. And you can see here how, so each of those nodes there could be like a different country. You've got the size of them, so you can see, kind of get an idea of how many employees would be inside of a country. All the ones kind of in the center are like more connected than the ones on the outside. And so you could get some interesting insight out of this, right? By seeing maybe small nodes in the middle, which are highly connected to other nodes outside, like so. So anyway, let me just give you a little demo of that. So Yoda's species, and so you can kind of click into these. And what's happening on the right over here is basically showing all the management lines in and management lines out, right, of a country. So some interesting insight that you could actually get from that. Okay, where to from here? So organizational design. Other cool things about this package here is that you notice that there's this little edit button up the top here. So you could actually take this visualization and start to kind of redraw it. So you could start to reorganize your company. So this could be useful for, like, say, mergers or acquisitions and stuff, and basically redraw the management lines to say, okay, well, I want this to kind of hook up this way. Now, if you're doing this kind of stuff, you probably want to save it. And this is where kind of a database like Neo4j would come in quite handy, because then you've got some persistent storage for your analysis, as opposed to just the analysis which is done in R. Okay, this is another interesting use case here. So you could apply this to a lot of different things, but one of the top use cases for graph network analysis right now is recommendation engines. So we could use this for internal job recommendations. So here's like a little example here. We have a job, okay, which requires the skills R, Neo4j, machine learning, and then we could try and match this to a person who has those same skills. Now, this is kind of like the simplest case here, but what if you don't know what skills that person has, right? Well, then what you could do is maybe something a little like this, where, okay, well, that person currently works in a job, and that job requires a certain amount of skills, right? And so you could basically infer what that person's skills are from the job that they're in. Now, this here, I've also added an extra node, which basically shows that this is not a 100% match. This is, say, a 75% match, and you could add something a little bit more sophisticated to this to end up with some better scoring or ranking, but you can do that as well, potentially match against multiple employees. I don't know, who here has heard of the Amazon 2 pizza teams? Okay, so basically, the story goes that a bunch of Amazon managers went to an offsite and they basically said, how do we improve the organization? Let's improve and increase communication. Jeff Bezos turned around and said, no, communication is terrible, which is kind of somewhat counterintuitive, but you know, if you've seen this formula here, right, then that kind of might make a little bit more sense. So this is basically modeling a fully connected network. And what happens when we increase the number of nodes and how many communications need to take place in a fully connected network. So as you can see here, by doubling the size, it goes up, you increase the size by 4.5 times. And you know, by increasing it to 50 employees, we end up with this ridiculous 1,225 lines of communication, which is just kind of makes it impossible to get anything done. Okay, so this is, I think this is my last slide here. So this is just basically how do you make more agile teams? You usually have to work across the organization to get things done. But anyway, I'm already at time. So if you want to check out my website and stuff as well, it's www.datastrategywithjonathan.com. And so p/graphs is kind of the website where you can just download the kind of free code for some of the graph examples that we did here. And I kind of thought I'd put this together as well. So I have a course on Shiny, teaching Shiny and Flex dashboards, which I think is a really, really fast, easy way for making Shiny dashboards. And you can go there and download a copy for free. So I hope you found that helpful. And yeah, any questions?